Now let us continue and let us try to find the ACR function array of 1. It will be same as array of -1. Both will be one and the same. How many possibilities we saw? There are 4 possibilities, right? So I ranges from 1 to 4, ak into ak -1. Okay, that's how we find the product of the 2 random variables which are adjacent to each other in this case. So I don't know why people join at whatever time they want. Shashank, next time you're coming in so late, you won't be allowed. Even Sujit. So you substitute the values. Here we have already computed the products. So 0, first one, 0 into 0 is 0 square into 1 by 4. 3 cases I have of 0 into 1 by 4, 0 into 1 by 4. And the last one is minus a square into 1 by 4. So what's the total value? This autocorrelation function will be minus a square by 4. Okay. So this is the value of the autocorrelation function array of 1, which is same as array of -1. This is equal to array of -1. Both are same. Let me give some equation number 4. Okay. Next, as a third case of this finding autocorrelation function, we can consider for all values of n greater than 1. Okay. So we can consider for all values of n greater than 1. Remember, now they are not adjacent. Now ak and ak minus n are not adjacent. Again, how many combinations? With 2 bits, ak and ak minus n are always 2 bits. So with 2 bits, we have 2 square, that is 4 combinations. As usual, 0, 0, 0, 1, 1, 0, 1, 1. The values of ak minus n. Here I am considering all values of n greater than 1, or I can take mod n, which means it's greater than plus or minus 1, because we took that as a separate case in analysis. So I can have both values as 0 and 0. Then the product of ak into ak minus n, the product would be 0, right? And I can take one of the values as 0. The other value would be what? Plus or minus a. For a 1, it is always represented with plus or minus a. Again, this can be plus or minus a, and this can be a 0. So we'll still get 0. When both are 1, what are the chances? This can be plus a. This can also be plus a and minus a and plus a, minus a and minus a. So I'll have 4 different chances for these bits to take. If this is plus a, this can also be plus a, one of the choices. This is plus a and minus a plus a, minus a, minus a. Since logic 1 is always represented with plus or minus A. Okay. So I can have these 4 different combinations possible. So how many, what will happen to the product? Plus A into plus A will be plus A square. Plus A into minus A or minus A into plus A will be minus A square twice. Again, minus A into minus A will be plus A square. So what do I get? I get an equal distribution of plus A and minus A, or I can write in general as plus or minus A square, right? Either I'll get plus A square or minus A square, and all the 4 are equally distributed. So how do I list the probability? The probability of all these 4 occurrences should be equal 1 by 4, 1 by 4, 1 by 4. And this last probability, I can divide it as probability of occurrence of plus A square as half of 1 by 4, which is 1 by 8. And the probability of occurrence of minus A square, which is again half of that 1 by 4, which is 1 by 8. Since here I have the possibility that it can be plus A or minus A square, plus A square or minus A square, I should split up and find out the probability of occurrence of plus A square and minus A square separately, which would be 1 by 8. Is that clear? Please ask if you have any doubts here. Therefore, RA of n, I should find. All this is for n greater than 1. So what would it be? How many possibilities are there for I? How many different values I takes? 1, 2, 3, 4 and 5. There are 5 different values, or though there are 4 combinations, the last combination results in 2 different values or 2 different probabilities. So it can take 5 values and AK into AK minus N into probability Pi. Okay. So you list all the cases. 0, the first product is 0 into 1 by 4. Second occurrence again 0 into 1 by 4 plus 0 into 1 by 4. Third occurrence also. The last one is plus A square into 1 by 8. And then the next one is minus A square into 1 by 8. So what will I get? All these 3 are 0. Plus A square by 8 and minus A square by 8. Again, I am getting the final answer as 0 only. You see, even in this case, we are getting for n greater than 1, the ACR function becomes 0. So you call this equation 4 or equation 5. Summarizing, the autocorrelation function RA of n takes the values. We have 3 different cases. For n is equal to 0, and let me say for n is equal to 1, which means plus or minus 1 I'm going to get. That's why I put a modulus. And then for n greater than 1, any other value other than these 3, any other value of n. Here I have 3 values. This means n is equal to minus 1 and n is equal to plus 1, 2 different values. What are the values we got? This last case is 0. Here we have found just here. Before that, the value was minus A square by 4. So for this, the value is minus A square by 4. And when n is equal to 0, what was the value? RA of 0 is A square by 2. So this is the value of the autocorrelation function in this example. So we have taken example of bipolar NRZ, and by considering the value of AK as per the waveform, we are showing that the value can be of array of n can be any of these things. Okay. So with this, we have completed step 2. Now we can move on to find step 3, which is to find the power spectral density. So to find the power spectral density, what is the equation used? Sx of f as usual is 1 by Tb V of f modulus whole square into summation n is equal to minus infinity to plus infinity Ra of n autocorrelation function into e to the power of minus j2 pi fn dB, right? So these are the values of the equation for the power spectral density. Substituting for this V of f, what would be the value of V of f? We know it would be Tb square sinc square ftb, correct? Or Tb sinc ftb the whole square. That's the expression for V of f. And then here I have 4 distinct values for summation. Here I'll say Ra of minus 1 into e to the power of minus j2 pi f into minus 1 into Tb. Remember here I am taking n as minus 1 in the first case, correct? So I have to take care of this n in the power of e also. Next is Ra of 0. Whatever values we have, I am substituting into e power 0 I'll get minus j2 pi f0 whatever. Next I have Ra of plus 1 into e to the power of j2 pi f plus 1 into Tb plus Ra for n greater than 1, any value of n greater than 1, e to the power of minus j2 pi fn Tb. So these are the 4 possible cases. So the summation here extends for all these 4 possible cases. We have included all the 4 cases in the summation. So now let me substitute this value. What is the value of Ra of minus 1? It is minus a square by 4. This is minus a square by 4 into e to the power of, what would I have here? This is going to become minus into minus plus j2 pi f Tb, correct? N value is minus 1 here. Then this is Ra of 0, which is a square by 2 into 1. E power 0 is 1 plus Ra of plus 1 is also minus a square by 4 into e to the power of minus into plus. This will remain as minus j2 pi f Tb plus this last term is 0. We know this Ra for n greater than 1. Here this is 0, right? So these are the 4 different cases which I have. Now let me simplify this. Tb sinc square ftb. Here a square by 2 term I will write it separately. Minus, if I take a square by 4 as the common factor, I will have e to the power of j2 pi ftb plus e to the power of minus j2 pi ftb. Any idea what can I write this as? What is e power j theta plus e power minus j theta by 2? What is this? This is equivalent of which function?
Cos theta.
Cos theta. So I can substitute for this. If I have only e power, therefore e power j2 pi ftb plus e power minus j2 pi ftb can be written as 2 cos, right? 2 cos 2 pi ftb. Here theta value is 2 pi ftb, and since I don't have divided by 2, if I remove this divide by 2, if I take it to the other side, it becomes 2 cos theta, right? Substitute this in this equation. Substituting, what do I get? Sx of f is equal to tb sinc square ftb into a square by 2 minus, can I write it as a square by 2? If I take this 2 inside here, I will get cos 2 pi ftb. Or if you want, you replace this as 2 cos 2 pi ftb, and you cancel out that 2 and this 4, this becomes like this. Any doubts with this? This is all only simplification we are trying to do. So what is 1 minus cos theta, or 1 minus cos 2 theta? What is cos 2 theta? All trigonometric identities we are here. Cos theta in terms of, I can write it as 1 minus 2 sine square theta, or 1 minus cos 2 theta can be written as 2 sine square theta. Is that okay? Yes or no? You are familiar with these identities, right?
Yes, ma'am.
Substitute that. I'm just trying to bring it to one standard form, that's all. And here a square by 2, if I take as the common factor, I'll get it as 1 minus cos 2 pi ftb. This I'll write it as tb sinc square ftb into a square by. So here I'm writing 1 minus cos 2 theta as 2 sine square theta. Here theta becomes pi f tb. Okay. So when I write this, the final expression for power spectral density becomes what? This 2 cancels out. I'll have TB sinc square FTB into sine square pi FTB. This becomes the expression for power spectral density. Okay, equation 6 or equation 7. Now, because of this kind of equation, how will the plot look? Let us try to plot the power spectral density. How would it look? I have a sine square function along with sinc square. So this is sinc square and next we have sine square. So it's a product. If you observe, you just try plotting individually. Each one separate points you take, it would look something like that. Say, how will sinc square look? Sinc square looks like this. This is sinc square FTB. And how will the sine square pi FTB look? Remember, a sine function has its value is 0 at 0. And what is square of 0? Square of 0 remains 0. So a sine square function will look something like this. Sine square pi FTB or sine square theta will look something like this. Okay, these values are 1 by TB and so on. It may vary slightly. Now if I combine both, you will have, let me draw this neatly. The combined power spectral density Sx of F, which is the product of sinc square FTB and sine square pi FTB, is, it will be 0 here at 0 because this value is 0, and you will see it will rise somewhere here. Again it will come down to 0 at 1, and then it will come down to 0 at 2. Okay, this is in terms of TB. When I plot, we call this as the normalized plot of power spectral density, and the maximum value which it attains would be 0.5. See, if you are still interested, you can take different values of F and TB and try to plot these individual responses and the combined response. Okay, you can just try to plot that. The bandwidth of this signal will be, as usual, 1 by TB. So this is 1 by TB, 2 by TB as on if I plot it as FTB. Okay, so here this is the curve. So what do you notice in this compared to the previous? In all the previous power spectral densities, at 0 we had maximum value of 1.5 whatever. Whenever I considered polar or unipolar, you see, observe the previous power spectral density curves which we have plotted. It's always maximum at 0. This one also, and even before this what we did here also, it's always maximum at 0. But this is the new power spectral density curve for bipolar, which is 0 at 0 frequency, or it does not have any significant DC values. So you just say no significant DC values. Therefore, AC coupled circuits may be used in the transmission route. So whenever I am transmitting, remember I will have repeaters and all that, regeneration repeaters and all. So in the transmission route, I need not have DC coupling circuits. I can use AC coupled circuits, which is an advantage. Okay. AC coupled circuits can be used in the transmission route. That is one significant advantage of this technique. And the second one is that here this is a disadvantage. This is advantage, I'll call it. How many different values or levels of voltage are there for A? A should have, or AK can take on 3 different values, plus A, 0 and minus A. So I can't use a simple switch. Switch will have only 2 states, that is either on state or off state, where it will either have maximum voltage or minimum or 0 voltage. You say realization requires a circuit which exhibits 3 different levels rather than 2 levels. So if I consider it as a MOSFET or a transistor, I should consider its third state also, say the high impedance state. So I have the 0 state, plus A and minus A. I need a state where either it will be maximum voltage at some point, minimum voltage at another point. So I need a hardware which will exhibit this kind of 3 different voltage levels, which is difficult. Therefore, demod or modulator realization is a bit difficult and a bit costly. So whenever you need to realize using some hardware which exhibits 3 different states, you should surely worry about how you will realize it, its cost, and also the cost as well as the difficulty in the realization. I hope this is clear to you. Any doubts with this bipolar? Only this plot, you just think over how it works. So step by step, you try to plot and see where it will maximize. Okay. Please go through this realization. I should send all this material today. And I have uploaded the remaining classes also. I think until class 12 or 13, I have uploaded. The rest I'll do it today. So if you don't have any doubts with this, we'll proceed to find the power. Now we have found the power spectral density of one polar format, one unipolar format, one bipolar format. So all 3 NRZ we have done. Now we'll do the last one, the Manchester signaling format or the Manchester line coding format. So let's try to find the power spectral density of the Manchester signaling format. Try to recollect how do we represent the Manchester coding. logic 1. How do I represent a logic 1 and how do I represent a logic 0? Logic 1 is represented with plus A for half the bit duration and minus A for the next half of the bit duration. First half of the bit duration, it is represented with plus A. So 0 to TB by 2, and from TB by 2 to TB, it will be represented as minus A. Similarly, how do we represent 0? Minus A for the first half of the bit duration and plus A for the second half of the bit duration. A 0 is represented with minus A for first half and plus A for the second half of the bit duration. Is that clear? Again, I have a logic 1, which means first positive, then negative. So this is called Manchester format. Okay, this is how we represent the symbol. Therefore, I can write the equation for AK. The discrete random variable AK will have, how do I represent this equation? It will take the value plus A here in the interval 0 to TB by 2 and minus A in the interval TB by 2 to TB, and both these for logic 1. Whenever the bit is logic 1, it will take the value plus A in the interval 0 to TB by 2 and minus A in the interval TB by 2 to TB, as we can see. Similarly, when it is logic 0, it will take the value minus A in the interval 0 to TB by 2 and plus A in the interval TB by 2 to TB for a logic 0. Okay, we'll call this as equation 1. The first part of our definition is this. I hope this is clear. We have written so many times till now. So the first part of our job is done. That is defining the discrete random variable AK. Now, as usual, I should assume the probabilities or find the probabilities. So assuming all symbols are equiprobable, all symbols are equiprobable, I can say probability that AK is equal to plus A should be equal to the probability that AK is equal to minus A, and both should be half. If I consider 4 possibilities as shown here, all these probabilities will be 1 by 4 each. Yes or no? If I consider getting logic 1 with probability half, then the probability of occurrence of plus A will be 1 by 4 and minus A 1 by 4. Or in general, if I remember for every symbol, I should have plus A minus A. So if I have to take all this, I should add these 1 by 4 plus 1 by 4, which will result in half here. Again, this 1 by 4 plus 1 by 4, which will result in probability half. That's how I get this. So occurrence of 1 and 0 are equiprobable. So probability of getting plus A or minus A. There are 2 plus A's, 2 minus A's. So probability of getting both should be half. Okay. So actually this is same as in what? This was the same which we got in NRZ polar format. So can you try to define what happens to the ACR function, which will be similar to that of NRZ polar? So step 2, ACR function you should find. You find first for n is equal to 0 and then for n not equal to 0. Two conditions. Please drop in your USNs in the chat box. So when I substitute the two different values of AK, it can either be plus A into plus A with probability half, or AK can take the value minus A into minus A with probability half. So this will be A square by 2 plus minus into minus is plus, which will be half plus half is 1, right? A square it would be. And similarly for n not equal to 0, it will be 2 square 4 combinations. You just list those 4 combinations and try to find the value of AK and AK minus 1. 0, 0, 0, 1, 1, 0, 1, 1. I want you to try this at home. You can finish it at home and try to write these values. Tomorrow we'll find the power spectral density. And we have something extra in this also. The wave shape is different, so think over that and come. I think still all of you haven't entered your USNs. Anybody yet to enter? You can all, if you have entered, you can leave. We'll continue tomorrow.